Hello everybody, myself Preet Raitata, and today I am here with the topic the multiplication algorithm. What is multiplication algorithm? Multiplication algorithm is an algorithm or a method to multiply two numbers. Depending on the size of the numbers, different algorithms are in use. Effective multiplication algorithm have existed way back from the decimal system. That is, for example, we can multiply 23 into 19. Now we can convert it into binary number. That is 23, it is represented as 10111 and 19 is represented as 10011. So here we have done the multiplication. 1 into something is also a number itself. Similarly, 1 into something is the number itself. 0 into something is the 0 and 0 is something is 0. 1 into something is the number itself 10311. So now we can add using the binary addition rule. 1 plus 1 is equal to 0 and carry over 1. Similarly, 1 plus 1 plus 1 is the 1 and carry over 1. So we have used this concept of the binary addition to add these partial products. So now we can go to the next slide. First, instead of as many number of the register as there are bits in the multiplier, it is convenient to provide an adder for the summation of only two successive binary numbers. Means there are many register, many numbers, many multipliers, there are many bits in the multipliers. We can provide an adder for the summation of only two successive binary numbers. We can do two things. Instead of shifting the multiplicand to the left, we can shift the partial product to the right. Similarly, when the corresponding bit of the multiplier is 0, there is no need to add all zeros to the partial products. Means whenever there is a multiplier bit is 0, we do not have to add any partial products. There is the hardware implementation of this multiplication algorithm, that is BS and B register. B register consists of multiplicand, and then complementer and parallel adder. Parallel adder we are using for which summation of the two binary numbers, successive binary numbers. Then a register, that is a temporary register in which we will store the value of whatever the summation we will get. Then and in Q register we will have the multiplier and we will have QS, that is sign of the Q register. What is the sign of the QS? And similarly we have also AS, that is the sign of the A register. We have E, that is enable or the carry, and we will have QN, the rightmost bit, that we will help to get what the answer it is. That is sequence counter we will have. Now we will learn about what is this, all the things. The multiplicand is in the register P and the multiplier is in Q. The SC is initially set a number equal to the number of bits in the multiplier. That is, multiplicand is in register B that I have explained earlier. Similarly, multiplier is in Q that I also have explained. And what is SC and how we will get the SC bits? SC bit is equal to the number of bits in the multiplier. The counter is decremented by 1 after forming each partial products. That is SC is sequence counter and it will be decremented after each partial product. The sum of A and B forms a partial product which is transferred to the register EA register. Both the partial products and multiplier are shifted to the right, that is shifting right EAQ. We will learn about the arithmetic right shift. Don't worry. What is right shift? We will learn about it. The LSB, that is the least significant bit of A, is shifted into the most significant bit of Q. We will do the right shift, arithmetic right shift. The bit from E is shifted into the MSB of A. Also, of the E bit, we will shift it into the A, that is the most significant bit of A. And O is 0 is shifted into E. In this manner, the rightmost bit of the multiplier and the one which must be inspected next. Okay, that is Qn. What is arithmetic shift right? The arithmetic shift right leaves the sign bit unchanged and the shifts the number including the sign. That is, we do not have to, only we will learn about the what is right shift, arithmetic right shift. 0 to 0, 0 to 0, 1 to 1, 1 to 1, 1 to 1. That is, we can shift the number to the right itself. This is the flow chart, how we will learn and how we will learn about the multiplication algorithm. It is the flow chart of the multiplication algorithm. It is easy to understand in this flow chart. First, the multiply operation. For example, we will have B 23, Q 19, 23 into 19. We will have AS, that is QS or BS, means the sign bit. What will be the sign bit of AS? We will depend on the QS bit and QS sign, मतलब Q sign and B sign. Similarly, in Q sign, we will have the Q sign and B sign. A, we will make it to 0, E also 0, and ST n minus 1. That we will explain, we have explained it about it, that the sequence counter is 1 less every partial product. What is Qn? Qn is basically the rightmost significant bit of the Q, that is multiplier, which is very important. If Qn equal to 1, then we will add the B, that is multiplicand, to our answer A. And if it equal to 0, then we will only shift right of our EQ value. And then we will make the sequence counter minus 1. First, if equal to 1, then we will add, and then we will also shift right, and then we can process sequence counter, that is SC minus 1. And if SC equal to 0, our process is ended. Our product is in AQ. And if it is not equal to 0, then the process follows back to Qn. This is the final example in which we will learn about it. That is, multiplicand is B equal to 10111 and our multiplicand is 10311 and our Q is 10011. Right? First, the multiplier in Q. First, E will be 0. Initially, we will have learned about it in the previous flowchart. A equal to all zeros. Q, that is the multiplier, 10011 and SC, that is 5. Y 1 2 3 4 5. How many bits are there? That is SC equal to 5. Now here Qn equal to 1, that is the last bit. Qn, here I've seen this last bit is equal to 1. So what we will do, we will add B in our A answer, that is A plus B. We have learned earlier, that is 10311. We have got 10311. Now what we will do, we will shift right, that is shifting process. 1 is shifted also right, here 0 1 1, and from A we have shifted 1 here, now 1 here, 0 here, 0 here, 1 here, and the 1 will discard it. Okay, now we have done it all the process. First we have added the number, then we have shifted right. So now we will do SC minus 1, that is 5 minus 1 equal to 4. So here it is 4, right? Now we will do the second process. We will see about the once again the Qnth bit, it is 1. So Qn equal to 1, then also add B. Once again we will add B. Now we had first learn about the binary addition in back slides. So 1 and 1, it is 0, carry over 1, 111, 1, carry over 1, 1 and 1 0, carry over 1, 1, 1 0, carry over 1, so 0. And now we will have carry, that is 1 here. The carry will go to E, correct? Right? We will carry will go to here, that is E. So we will get E equal to 1 and the addition 0 0 0 1 0, right? Now what we will do, once again we will shift right. So 1 will go here, 0 will here, 0 here, 0 here, 1 here. So now 0 will go here. Now from 1 1 0 0, right? We have also done here shift right. Then from 4 we will get 3. Now 3 process, right? Correct, done. Now we will get what? The less significant bit, that is Qnth bit. Here is 0. So we do not have to do anything. We only have to shift right. So 0 to 0, 1 to 1, 0 to 0 shift, 0 to 0 shift, 0 to 0 shift, 1 to shift here, right? 0 to 0 shift, right shift, 1 to 1, 1 to 1, 0 0, right? Okay, now we have also shift right. So 3 minus 1, that is 2. We have get 2. Sequence counter when SC equal to 0, then our process has been stopped, right? So let's get started. What is this? 0. We will get 0, shifting right. S qnth is also 0 now. So we will shift right, 0 to 0, 0 to 0, 1 to 1, 0 to 0, 0 to 0. Now here we get 0 to 0. Oh no, 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 sorry, wait a minute. Right? Sorry for the delay. We'll get 0 to 0 here. 1 to 1, that is shifting right. Once again we have shifted right, 1 to 1 and 1 to 1, right? Now we had shifted right, so our also task is over. So now sequence counter will be 2 minus 1, that is 1. So it is the last step. From that we get 1 minus 1 equal to 0. So in this we see qn equal to 1. So we will add the number, that is 10311 will be added, correct? 0 to 1 1, 0 to 1 1, 1 to 1 0, 0 0 1, 0 1 1. That is binary addition we will do. Now we will final the step. It is shift right, correct? Done. Done. We have done all the things, right? 0 to 0, now shift 1 0 1. We have done all the process. Now what will the final answer? That is EAQ. This will be our final answer, and we have final answer, not E. We have only AQ as the final answer, right? We got the answer, and that is the final answer. Thank you.